Assalamu alaikum. I am Sumaya Abdul-Jawad, a student in pharmaceutical technology at International Islamic University. The topic for today, or the study's title, is Layer by Layer Encapsulation for Sesame Oil in Chitosan-Alginate Matrix for colon targeted delivery. So the active ingredients in this study is the sesame oil. And as you know that these days, the discovered medical effect for the natural oils make them very common in pharmacy. Sesame oil is one of them. And the rule of it is antioxidant and anti-inflammatory action at the same time. And specifically, it works in the colon side. And that's why we're choosing it for our study. The coating for the sesame oil gonna be by using alginate and chitosan, and both of them are polysaccharides, and they are preferable in medicine or in pharmacy because they are having biocompatibility and also biodegradability features. We are choosing both of them, alginate and chitosan, together because they are stable in different pH media. As you know, that alginate will be stable in the low pH media, and chitosan will be stable at the high pH media. The method for this study will be layer by layer encapsulation. And we are using it just to target the colon site. And that will allow us to cover the beads of the sesame oil by multiple layers. Each layer will be stable or will be suitable for the gastrointestinal tract. As you know, or as we mentioned in the previous slide, that alginate have different pH media for the chitosan. So one will work for the stomach and another one will work for the intestine. Objectives for the study is to design and to characterize a formulation of encapsulated chitosan-alginate beads of sesame oil. And after that, we are going to determine the release of sesame oil in the gastrointestinal tract by using simulated buffer. This is the first thing we did in our research, just to prepare the beads of the alginate sesame oil. We are mixing here the oil with alginate, and we are pumping the emulsion just to the solution of calcium chloride, and the beads were formed. The concentration of the calcium chloride was 2%, alginate also 2%, and 10% for the sesame oil. So through the needle here, we are dropping the emulsion to the calcium chloride solution. And actually we are using this pump in the picture. And through the pump here, by using the needle, we are dropping the emulsion to the calcium chloride, and beads are formed. During the study, or during the preparation of the beads, we were doing the stability test for the emulsion. So it was stable at 2 hours, as you see in the picture, also 4 hours, and finally 6 hours. Here is the picture for the beads while it was wet. And the second one here, after we dry it out for 24 hours by using the oven at 60 degrees. After drying out the beads, of course, the size will be smaller, and we checked for the size by using a digital microscope and ImageJ program. Here, as you see, the information about the size, the area, and everything about the beads. Here, the method of the layer by layer coating. So after preparing the sesame oil alginate beads and it dry out, we are using it for the layer by layer technique. We are using alginate here and also calcium chloride for the cross-linking. We are using chitosan and tripolyphosphate for the cross-linking of the chitosan. So the layer will be two, one for the chitosan and another for alginate. The first one we'll start with is the chitosan. We are making cross-linking for the chitosan layer by TPP. Then we move to the alginate, and we are making cross-linking for the alginate layer by using calcium chloride. Here is the time for each step: 15 minutes for the Chitosan, 2 minutes for TPP, and 15 minutes for the alginate. And finally, we have the 5 minutes for calcium chloride. This is the picture for the real step, as you see it, first, second, and third, and fourth one. First checkup we did it, or the first study we did, is to find the difference between coated and uncoated beads. So we put both of them in the simulator intestinal buffer, which was 6.8 BH, and we see the behavior or the drug release amount of the sesame oil in coated and also in uncoated beads. So the coated one, as you see, it was 0% of the drug release during 3 hours. Another one, the uncoated one, it was really high. It reached 61% of the drug release during 3 hours. Then we did the sequence for cumulative drug release in 1.2 BH, which is considered as the gastric, simulated gastric buffer, and it was 0. And then it begins to be high, the drug release, during 6.8, which is the intestine media. It takes 4 hours and 15 minutes, and the drug release percentage was 71. Here, another experiment we did it. As you see, that it was same for the previous one. We just add the washing step after each layer. So after the Chitosan, we are adding the washing for the beads for 5 minutes and so on. That will provide for us the Chitosan layer will stick strongly to the alginate and also make sure that there is no sticky materials to the beads and connection will be strong. In this experiment, we are trying 2 kinds of beads. One is wet and one is dry. The wet beads means that after calcium chloride solution, we did not let it dry out and we check it directly in the simulated buffers. While the dry one, we let it dry out and then we check it in the simulated buffers. This is the result for layer by layer coating with TPP and also the washing step. It's same for the previous one. As you see, 1.2 BH. The gastric simulated buffer was same, but it increased really high once it reached the 6.8 media, which considered as intestine simulated buffer. And that was for the wet beads, 38.5% of the drug release, while the dry one, the result was 73.4% of the drug release. Both of them get 4 hours to show this result, and that's mean washing did not help. As you see that the drug release percentage is high and also the time is less. So here, as a next step, we decided to remove the TPP from the method of layer by layer coating. And we did that because we noticed that TPP, after using TPP, there are turbidity in the solution, and also it makes a little bit of precipitation. And we realized that it happened because of the interaction between the calcium chloride with TPP. So that's mean alginate will not connect strongly with the Chitosan layer. So after removing it, we will get a good result and better connection between Chitosan and alginate. So we did the same steps, just we removed the TPP after using the Chitosan. We put the beads directly to the alginate and finally to the calcium chloride. We are using here first distilled water, and then we are adding the alginate to the distilled water, so the concentration will be 1%. Same thing for the calcium chloride. And all that just to make sure that the beads will be one by one, not collapsed or connected together. This is the result. Before the result, the pictures or the real pictures for the coating. And this is the result for coated without TPP. So here we got a good result. The time was more. It's 5 hours now, and that drag release was less. It was 40% for the wet beads, and it was 64 for the dry beads. That means there is an improvement in the time and also improvement in the drag release percentage. This is the picture for the wet, as you see here, the 40%. And the next one is for the dry beads. So that means removing the TPP give us a good result. And that was one of the steps to improve the layer by layer coating for the sesame oil. As a conclusion, we can say that we achieved or we designed a formulation of encapsulation sesame oil by using chitosan and alginate, and we achieved 5 hours with 64% of drag release. Next step is to keep improving the formulation until we have less cumulative drag release, and at the same time we have more, or we increase the time until 6 hours. How we can do that? We have a suggestion by using the same method of layer by layer, but we want to exchange between the chitosan and the alginate layer to make chitosan first and then alginate. We are gonna get better result, inshallah. This is the references, and thank you for listening.